So this was the 2011. It was a non-calculator 2011. It was from Form B. So if you want to find the scoring guidelines online for this one, you can. But I'm going to basically tell you what you needed to do for everything anyway. So for part A, where you're asked to find the area of this region, you had two different possibilities. One was to do it in terms of x. And if you do it in terms of x, because the upper function switches from the square root function to the linear function at x equals 4, you'd have to split it into two different integrals. Or you wouldn't even have to do an integral for the second piece, because the second piece is a triangle. You could just find the area of that triangle. So one option for part A was the integral from 0 to 4 of root x dx plus, and I'm not even going to bother to write the integral. You could write the integral from 4 to 6 of 6 minus x, but I'm just going to say 1/2 the base, which is 2, times the height, which is also 2. And that's one way you could do it. You'd integrate the root x to get 2/3 x to the 3/2 from 0 to 4. And I guess I should write plus 2 at the end of that. And what does that come out to be? X to the 3/2 is 8/3. Or I mean, is 8 times the 2/3 gives us 16/3. So 16/3 plus 2 gives you 22/3. And so if you did it that way, 1 point was for having the right integral, 1 point was for taking the antiderivative correctly, and 1 point was for getting that answer. And you could have also done it in terms of y. And so this function would have been x equals y squared, and this function would have been x equals 6 minus y if you rearrange each of them to solve for x. And so you'd have done the right function minus the left function, dy, from the lowest y value to the highest y value. And you'd have to integrate that and evaluate it out, and you'd get 22/3. And so it'd be 1 point for the right setup, 1 point for the right integral, and 1 point for the right value of 22/3. Good or no?
Wait, so having like that triangle area formula instead of like writing out the integral, that still counts as the point?
Yeah, you can do that. Yeah. I mean, remember we did that, we added and subtracted some area pieces way back when. So same thing, same concept. If you wanted to write it though as an integral from 4 to 6 of 6 minus x and do it that way, that's fine. I think this is easier. Everybody good there? All right. Part B then tells us that the region R is the base of the solid, and that cross sections perpendicular to the y-axis are rectangles, and their base lies across the region, and their height is just 2y. So all we need is an integral expression to give the volume of it. So the area of each one should be the base times 2y. And so all we need to do is integrate from 0 to 2 at 2y times the base. And the base was, like we said before, 6 minus y squared. dy at 6 minus y squared just comes from the length between the rightmost function to the leftmost function. And we have to do it in terms of y, which should be pretty obvious since they're telling you from y equals 0 to y equals 2, and it gives you the height in terms of y. But it says that the cross sections are perpendicular to the y-axis. It's got to be in terms of y. Any questions there on part B? All right. Part C says there is a point on the graph of f where the tangent line to f is perpendicular to the graph of G. And we want it to find the coordinates of point B. So if the line is perpendicular to G, what should its slope be? What is the slope of something perpendicular to G? What is the slope of G? Slope of G is -1, right? Which you can either get by just knowing the slope of that line or by taking the derivative and getting -1. So what's perpendicular to that?
1.
1. So we want to know, when does F have a tangent line with a slope of 1? So we're looking for the tangent line's slope equal to 1 for F. Well, the tangent line's slope is F prime. So we want to know, when does F prime of X equal 1? And F prime of X is 1 over 2 root X. So we want to solve that for when that equals 1, solve for X. Should give us what? X equals, multiply by that, right? So root X equals 1/2, so X equals 1/4. And the square root of 1/4 for the Y value, right? Y equals square root of X equals Y, which is square root of 1/4, which is 1/2. And so the coordinates of the point are 1/4, comma, 1/2. Good or no? Any questions there? All right. And this one was a calculator question. You were asked to find the area of this region. So very similar to the last one, except instead of having square root of X, we have ln of X. And we can do this 2 different ways. We can do it in terms of X, and where we'll have to split it at this intersection point. Or we can do it in terms of Y, and just do the right function minus the left function. But we still need to find this intersection point, because if we do it in terms of X, we need to split our integral there. If we do it in terms of Y, that's the upper limit of our region. So how do we find that intersection point?
Set them equal.
Exactly. Natural log of X equals 5 minus X. You gotta use your graphing calculator to figure that out. I believe that came out to be, well, I don't believe, I trust the scoring guide, 3.69344. And if you take the natural log of that, you get the Y value. Or if you do 5 minus that, you get the Y value. And that Y value came out to be 1.30656. So those are coordinates. And you can set up this integral one of 2 different ways. One way would be, and I'm just going to call this A, comma, B, just to simplify things so I don't have to write these numbers out over and over again. But we could say an integral from 0 to A of ln x dx plus an integral from A to, where does this intersect at? 5, right? From A to 5 of 5 minus x dx. So that's one option. Or if y equals ln x, x equals e to the y. And if y equals 5 minus x, then x equals 5 minus y. So we could have done an integral from 0 to b of the right function, 5 minus y, minus the left function, e to the y, dy. Everybody see that both of those would have worked? Everybody good with part A?
Yep.
Okay. Oh, and you needed to actually evaluate it. So what did that come out to be? It came out to be 2 point something, 2.986, I think. So you would have got 1 point for having the right things inside the integral, 1 point for having the right limits, and 1 point for having the right answer. And you need to show natural log x equals 5 minus x, and then just put the value. You need to at least write this equation out to show how you got those intersection points. All right. Part B now says that this is the base of a solid and the cross sections are perpendicular to the x-axis. So if they're perpendicular to the x-axis, we're going to have to do it all in terms of x. They are squares. And so we need to write an expression involving one or more integrals that gives the volume of the solid. So we're going to do it in terms of x. We're going to have to separate it at A, and the side length of one of the squares is just natural log of x, and so the area of that should just be natural log of x squared dx. And the other one should be an integral from A to 5 of 5 minus x squared dx. Good or no?
Good.
All right. Part C. Part C says we got some horizontal line that divides this region into two sections of equal area. And we want to write, we don't need to solve it, an equation with one or more integrals that gives us the value of k. So first off, we know the area of the entire region, right? It's 2.986. So one of these, the area that we're talking about, needs to be 1/2 of 2.986. True? And so we'll need to write an integral that gives us the area of this section that I've shaded in red. Hold on 1 second. Okay, sorry about that. So we need an expression for the area of this region that I shaded in red. So that should just be the rightmost function minus the leftmost function, integrated from the lowest value of 0 to the highest value of that region, which is k. So we'll integrate 0 to k of 5 minus y minus e to the y dy. And that would be our expression. That would be our integral. And if we wanted to, we could solve it, right? We could integrate this and get 5y minus y squared over 2 minus e to the y and plug in k's and plug in zeros. Or we could use our graphing calculator to solve that equation and actually find the value of k, but we don't need to. Does that make sense? That setup for that last one?
I have a question about this one. Could you write the integral of 0 to k of that whole thing being equal to the integral of k to I think it's 5 of that whole thing as well, or like to the top of the thing?
It wouldn't be 5. It'd be k to 1.3065.
Right, that number. Could you write it like that?
Yeah.
Okay.
Yep, that'd be fine. Just, yeah. You don't have to do that. You can do it this way too. Either way is fine. Yep. And on a separate note, suppose you got the answer to A wrong. Right? You didn't get 2.986, you got something else, you got 7 or something like that. Well, if you put in 1/2 of 7 here, they'd still give you the points for part C. So they don't penalize you for being wrong in part A if you need the answer from part A to solve part C. So they'd still give you the points for part C. Good or no? All right. So we are now on to the derivatives multiple choice. So here's how we're going to do this. If you have questions from the derivatives multiple choice, just type them into the chat, the numbers that you'd like me to do, and I will just go through and do them in order. I assume you all have lots of questions on them. All right, now we're going to start with number 20. So I'll just do them in the order you guys type them in. So oh my, all right, there's lots of questions now. So first one I got was 20, so we're gonna start with 20. Then we'll move on to all these other ones. So I believe 20 was just asking you to find the derivative. And so they're giving you the function inverse sine of x minus root 1 minus x squared. So first off, derivative of inverse sine of x is 1 over root 1 minus x squared. And then the derivative of the square root of 1 minus x squared ought to be, this is square root of u, so it ought to be 1 over 2 root u times the derivative of what's inside of there, which is negative 2x. The 2 should cancel there, and the negative should become a plus, so this should give you 1 plus x over root 1 minus x squared, which looks like that is answer choice C. Everybody good with number 20 there? All right. Next one, 73. Flip through here to 73. Okay, so 73 wants us to know how many points on the interval from -5 to 5 is the tangent to y equals negative x, not negative x, y equals x plus cosine x. So when is the tangent line parallel to the secant line? And so in order to figure that out, the best thing we want to do is graph this on the interval from -5 to 5. Or you can just graph it and then specifically look from -5 to 5. So I'm just going to show it on Desmos. Here it is from -5 to 5. And our secant line is the line that goes through this endpoint at -5 to this endpoint at 5. And so what we need to do is figure out how many times it has that slope, how many times our function does. So here our tangent lines are definitely less, like right here where we're starting. Our tangent lines are definitely less than the secant line slope. But at some point over here, they become greater than that secant line's slope. Right? So we've changed from being less than it to greater than it. So that's one time, somewhere in between here. And then we go from being greater than that slope to less than that slope again. So that's a second time. Then we go from being less than to greater than that slope again, and that's a third time. So it looks like there are 3 times that it changes from less than to greater than that value. Does that make sense to everybody for 73? Okay. Oh, we got 2 people now. 78 was the next one, and somebody else just asked for 78. So number 78. Oh, no. Somebody said no. That doesn't make sense on 73. You have a question still on 73? Yeah. So let me repeat that. First off, let's see here. What is the? I know I can't get the actual value there at -5, but -4.715 and 5.264. So let's see, what does that slope come out to be? I mean, it's about a slope, 5.264 and 4. It's almost a slope of, in fact, it must be. No, it's not. Darn. Well, close. Let's see here. Let's make that. No, that didn't do it. I don't know. Let's see here if I increase that up by about that much. Try and make this a little easier to see. All right, that's not perfectly our secant line, but that's pretty darn close to our secant line there. So if we look at our slopes right here of our function, the slopes of our function are less than the slope of the secant line when we start. But somewhere over here, it transitions to having a slope that is greater than the slope of that secant line. So somewhere between here and here, we had the exact same slope as the secant line. We could sketch a parallel line right here. That's one time. Then we have a slope that's greater than that, that switches to a slope that is less than. So that's a second time. Then it goes from a slope that's less than to a slope that's greater than again. So that's a third time. Does that make sense? Okay. All right. So let's see here. What was I up to? 78. Yeah, 78 is a good one. I remember doing this one last period. So 78 says that we've got a function that's differentiable, and that difference quotients overestimate the slope. So what is a difference quotient? Right, a difference quotient is a slope. And what is it the slope of? What is a difference quotient the slope of?
Is it the tangent line?
No, the limit as h approaches 0 of the difference quotient is the slope of the tangent line. But just the difference quotient itself is just the slope of the secant line. It's just the slope of the line through any 2 points of the function. So suppose I have a function that is, let's say, concave down. Here's a secant line through any 2 points. If I am using the secant line to approximate the value of my function, right? What can you tell me about that? The secant line's value must be less than the value of the function. Do you all agree with that?
Yeah.
Secant line must be less than that value. What if my function was concave up? My secant line should be an overestimate for the value of that function, shouldn't it? Whereas a tangent line, the opposite is true. Tangent line should be an overestimate on a function that's concave down, but an underestimate on a function that's concave up. Does that make sense to everybody? So anywhere between A and B on a concave down function, secant line is less than the value. And on a concave up function, secant line is more than the value of the function. And if it's a tangent line and it's concave down, the value of the tangent line is greater than the value of the function. And if it's concave up, the value of the tangent line is less than the value of the function. So we are interested in when does it overestimate the slope for a secant line. So our secant line is an overestimate when our function is concave up. And a function is concave up if f double prime is greater than 0. And so that would be choice B. Does that make sense to everybody? And this is an important thing to remember about functions and their concavity and their secant lines and their tangent lines. All right. Number 84 is the next one. So for number 84, we are given f of A is equal to f of B is equal to 0. And we know that the function is continuous on A to B. And then it gives us a bunch of things that we need to say. One of them is true, or we can say that none of them are guaranteed to be true. Let's see. So choice A says that f of x must be identically 0. Well, that just means f of x is the function y equals 0. It's just the x-axis. That's, I mean, if f of A and f of B, like f of A and f of B are both 0, that does not tell you that it's always got to be 0. Right? Clearly, the function could do other things. Part B says that f prime of x might be different from 0. So the derivative may be different from 0 for all x on the interval from A to B. And so we might be led to believe that that is not true, but that actually is true, because we would think that according to the mean value theorem, or Rolle's theorem, since f of A is equal to f of B and they're both equal to 0, that would tell us that the derivative should be 0 somewhere on that interval if we were guaranteed that the function was continuous and differentiable on that entire interval. But it's possible that our function might not be differentiable on that entire interval, which tells us that we could have a place where the derivative is undefined, but where we still, well, I guess I need to should make it like this. We have a place where our derivative is undefined, where our function still equals A, or still equals 0, our other function still equals 0 here, but there are no places in there where our derivative is equal to 0. So it could be different from 0 on the entire interval. So they're trying to trick you with that one and making you think that it's the mean value theorem or Rolle's theorem, but it's not, because they didn't state that it's differentiable. Does that make sense to everybody? Hopefully that makes sense. And then the other choices, you go through and figure out why those ones aren't necessarily true. Okay, let me see here. Back to the chat and figure out what the next one is. 92 and 93. Yeah, so 92 and 93, they're talking about the symmetric difference quotient. Nobody ever uses the term symmetric difference quotient, really. If you see that, ever just treat it as difference quotient. So yeah, was that your only question on that? Is what is a symmetric difference quotient, or 92 and 93? Yeah, other than that, are you good with that? Just use the difference quotient and evaluate it out. Well, so it's just if it's equal to the actual derivative at the spot. So, I mean, so they've given, okay, so they've given you this definition for a symmetric difference quotient, which you don't need to know. So, yeah, I guess what they want you to do is just plug in the values that they give you into that little equation that they put up there, which is unnecessary and not part of this class, and I don't know why they would put that question in there. So you literally just do 4 to the 0.08 minus 4 to the 4 minus 0.08 over 0.16 and see how accurate that is to the actual difference quotient. So what you'd want to do is do 4 to the 4 to the 0.08 minus 4 to the negative 0.08 divided by 0.16. And so you would see how accurate that is, or compare that to the actual value, which you can use your calculator to find the derivative of 4 to the x at x equals 0. So and then you just compare the decimal points. And it'd be the same thing for 93. All right, let's see here. 49, 50, and 51 are our next ones here. So we got a few in order here. Let's see here. Flip back to 49. What are we doing with these ones? No specific instructions. All right, so 49, we're looking at the limit as x approaches 0 of tangent pi x over x. And so if we plug in 0 to this is the tangent of 0 over 0, so that's 0 over 0. And so you'll need to use L'Hopital's rule to find the derivative of the numerator and the derivative of the denominator to find this limit. So the derivative of tangent pi x is secant squared pi x times the derivative of pi x, which is pi, all over 1. And so then you'll plug in 0 to that. And you've got pi times the secant squared of 0, which is secant of 0 is 1. So you just end up getting pi for 49. That makes sense for 49, everybody? Okay. We don't need 50 anymore, apparently. Yeah, and 51 was a BC only question. I don't know. Maybe I accidentally cut off the little part that says BC only on 51, but 51 you guys wouldn't be expected to know how to do. Let's see here. 78. I think I already did 78, right? And then 74 is the next one I got here. 74. Okay, so 74 gives you a table of values. And everybody should have it out anyway, but I'll put out this table anyway. We got 1.92, 1.93, 1.95, 1.98, and 2. And then we got 6, 5, 4.4, 4.1, and 4. Good? All right, so we're looking to estimate f prime of 2. So the best way, given a set of values, to estimate the derivative of it all we need to do is find the average rate of change between two of the points that include 2. So we'll do 4 minus 4.1, y minus, or y2 minus y1, over 2 minus 1.98, which gives us negative 0.1 divided by 0.02. And let's see, if we move the decimals over on that, that's what, negative, what does that come out to be? Negative 1 over point, yeah, negative 5, looks like. That one good? Other questions? That's the end of the list of what people have asked so far. We have plenty more time. Either you guys are way better at all of this than second period, or you haven't done it and you're way lazier than second period. All right, number 90. Okay, so number 90, we are given a graph of this thing here. Let's see here if I can, this crosses through at 1. And yeah, the rest of these values aren't going to matter too much. So it says the rate of change of this function, so the rate of change of it would be its slope, is least. So we're looking at when is f prime the smallest? When is the rate of change the smallest? Well, that's going to occur somewhere when it's not positive, clearly somewhere in between here. And it will occur at the place where the point of inflection is. And the point of, it gives us these other values over here. Is like 2 is like right here. And so the point of inflection is somewhere to the left of 1, but definitely greater than 0. And so the only choice that they give you that's greater than 0 but less than 1 is 0.7. It's definitely not at 2.7, right? 2.7 is over here near where that minimum is. And anything less, the negative values, our rate of change is very large because we're at positive slopes there. Does that make sense? Whereas our derivative the smallest? When is our rate of change the least? Everybody good with that one? Any other questions? None of you have any more questions from the multiple choice for the differentiation? Okay, okay, so I can go back to 92 and 93. 92 and 93, if you look above those, they give you this definition of this thing that they're calling the symmetric difference quotient, which you don't need to know. I mean, you really don't need to know it. But all you're doing is you're using that formula with x not equal to 0. So let me go back to the page where I was talking about it. So you're plugging in, your function is 4 to the x, you're doing 4 to the x plus h, so that'd be 0 plus 0.08, minus 4 to the 0 minus 0.08, divided by 2 times 0.08. And then you're just seeing what that decimal approximation is and comparing it to the decimal approximation you get when you actually evaluate the derivative of 4 to the x at 0. And your calculator will do that for you. So you're just comparing these two values together. So 92 and 93, same. I mean, you do 92 and 93 exactly the same. These are the numbers for 92. But for 93, it'd be plug in 0.001 instead of 0.08. That makes sense now or no? Basically, what they're testing is, can you use your calculator to evaluate this value of f prime of 0 and then compare it to this one? Yeah, to answer your question, somewhere in the middle of this packet here, right after question 56, it says, part B, some of the questions require the use of a graphing calculator. So 1 through 56, you should have been doing without a calculator. 57 to the end, you should have been using a calculator as needed. You'll note that as you go through for all of the sections. There's a part B somewhere partway through. Well, not for all the sections, but there's a part B in most of the sections where they say you can use a calculator. Other questions? $76. Okay. Yeah, 76 is a kind of annoying one. We did that one last period. So 76, they're talking about the left half of this parabola, x squared minus 8x plus 10. So basically, x less than or equal to 4. And so they're calling it a one-to-one function, therefore it has an inverse that's also a function, and we're calling that inverse g. And so we want g prime of 3. The inverse equals g, and we want g prime of 3. And so we know that the inverse rule says that the derivative of the inverse should just be the inverse of this one's derivative. So 2x minus 8, if this is y prime. And so that means that g prime ought to be 1 over 2x minus 8. And so all we have to do is figure out at what value on our original function does g equal 3. And so we'll go back in and set x squared minus 8x plus 10 equal to 3, which gives us x squared minus 8x plus 7 equals 0. Factor to x minus 1, x minus 7, and find that there are 2 places where that's the case. And the one that we will need to plug in is the one where x is less than or equal to 4, which is x equals 1. And we end up with negative 1/6. Does that make sense? Is everyone good with that one? Other questions? Other questions?